All right, let's get right into it. If you think working with large language models is just about fiddling with prompts, you're kind of missing the bigger picture. We're going to be talking about a new, absolutely critical role that's popping up across the entire AI industry, the full stack LLM engineer.
And this, right here, this quote, is the key to understanding everything. For the longest time, the big, scary number in AI was the cost of training a model. But that's all changed. The real economic battleground now isn't about building the model, it's about the cost of actually using it.
And that, my friends, brings us to AI's billion-dollar problem. See, once you've built your shiny new AI, it has to actually answer questions for millions of people. And that process, which we call inference, is wildly expensive. It just burns through energy and computing power, creating this massive ongoing cost. So yeah, just so we're all on the same page, inference is the live show. It's the exact moment you ask a chatbot a question and it starts typing back. That's where the magic happens and the value is created, but it's also where the meter is running, and it is running fast. So, you've got this massive, expensive problem. Who are you going to call? Well, this is where our hero comes in, the full-stack LLM engineer. This isn't just a programmer. This is a highly specialized expert whose whole job is to tame that beast of inference cost and make these models actually work in the real world. And this really shows you the shift in thinking. The old view was super simple. Just write a better prompt. The new view, no way. It's a whole discipline. You have to understand everything, from the silicon chips all the way up to the user interface. It's the difference between knowing how to drive a car and being the person who can design the engine, build the chassis, and win the race. Okay, so what does a day in the life of one of these engineers actually look like? What are they doing all day? Well, you can pretty much break their job down into 5 core missions. Each one is absolutely essential for making AI practical, cheap, and safe enough to use at a huge scale. And you can see right away, this is so much more than just plugging in an API. They're down in the trenches, optimizing the actual pipelines to make them faster. They're building these incredibly sophisticated ROG systems to make the models smarter. And they're the ones putting up the guardrails to make sure everything is reliable. It is a massive job. Let's just zoom in on that first mission, optimization. Because honestly, this is where things get really cool. These engineers use all sorts of tricks, like quantization. You can think of it like taking a giant high-resolution image and saving it as a smaller JPEG. It's not exactly the same, but it's way, way faster. Every single one of these techniques shaves off precious milliseconds and, in turn, saves a ton of money.
Next up is RAG, or Retrieval-Augmented Generation. You've probably heard this term. The best analogy is giving the AI an open book test. So instead of trying to remember everything it ever read on the internet, it can look things up in your specific documents. The engineer's job is to be the master librarian who organizes that whole system, deciding how to chop up the documents and how to find the perfect piece of info in a split second. It's a really complex dance.
Now, you can't do all this stuff with just a simple text editor, right? These engineers are working with a whole toolkit, a specialized arsenal of software and tech that's been built specifically for high-performance AI. And just look at this list. It really gives you a sense of how broad their expertise has to be. You've got your serving frameworks like VLLM, you've got vector databases like FACE for that super fast retrieval, and of course, all the core libraries like PyTorch. The key thing here is that they're not just users of these tools, they're expert orchestrators who know exactly how to combine them to build something incredible. So we know how they do it, and we know the tools they use. But what's the end product? What are they actually building at the end of the day? And it's some pretty impressive stuff. We're talking about the actual custom-built servers that can handle millions of requests without breaking a sweat, or these advanced AI agents that can remember conversations and use other software tools. And maybe most importantly, they build the safety layers that keep the models from going off the rails. They build the foundation that turns a cool demo into a reliable product. And all of this, it brings us right back to where we started this whole conversation, the million-dollar millisecond. It all boils down to the massive economic impact of this job, where pretty much every line of code can be tied directly to the bottom line. I mean, seriously think about it. When you're dealing with millions of users making requests every second, saving a single millisecond, a thousandth of a second, translates into huge, massive cost savings. It's a game of inches, but the prize is potentially millions of dollars.
But you know, it's not just about saving money. That's only half the story. The other side of the coin is quality.
That tiny 1% improvement in how well the model answers a question, that is the difference between a user going, "Wow, this is magic," and them just closing the tab in frustration. It's everything.
Which leaves us with one last big question. As AI gets woven into pretty much everything we do, isn't the person who can bridge the gap, the person who makes it fast, cheap, safe, and actually good, the most important person in the room? Are we looking at the most critical engineering role of the next 10 years? When you look at where everything is headed, it's pretty hard to argue against it.